Alright, on exercise here, it says the radius of Jupiter is about 11 times greater than the radius of the Earth. Look at the picture. You can see it's gargantuan. How many times as great as Earth's volume is Jupiter's volume? It's kind of weird wording at the end. It's just asking how many times bigger is the volume of Jupiter than the Earth. Okay, so is it 11 times bigger? Answer is nope, it is not. Okay, so the volume of each of these is given at least approximately by the formula down here at the bottom. This is the formula for the volume of a sphere, 4/3 pi times r cubed, where r is the radius of the sphere. These are roughly spherical, so we can go ahead and use this formula. So let's just assume that this one then is the volume of the Earth with whatever its radius is. Okay, Jupiter's radius is 11 times that. So the volume of Jupiter, if you can see my little white pen here, is equal to still 4/3 pi, but this time I have 11r that I'm cubing. Okay, so I'm cubing 11r. So I get to use the power property on this one, and each one of the things inside the parentheses has to be raised to the third power. So this is 4/3 pi times 11 cubed times r cubed. Let's go ahead and take this 11 cubed and bring it out front, because it's what distinguishes this one from the one from the Earth. So this is, whoops, I said bring it out front and then I go not bring it out front. 11 to the third power times 4/3 pi r cubed. So I can clearly see that the volume of Jupiter is 11 to the third times bigger than the volume of the Earth. 11 times 11 times 11. That's really, really big. That's exactly what that number is equal to. Really, really big. Okay, so the next exercise, the area of a rectangle is 16a cubed b to the 5th c to the 9th unit squared. Weird, whatever. Find the length of the rectangle if its width is 2 times a squared b c to the 3rd units. Okay, so I know whenever I'm going to find the area of a rectangle, its formula is length times width. Okay, but what we're trying to do is we're trying to find the length here. So if I take this formula and solve it for length, I would have to divide the w over, right? So this means that the length is equal to area divided by width. So now just use the expressions that they gave me in the problem. 16a cubed b to the 5th c to the 9th. That is the area of the thing, and the width of it is 2a squared b c cubed. Okay, and now let's just simplify the expression as we've done before. 16 divided by 2 is 8. The 3 is bigger than the 2 on the bottom, so just subtract it. 3 minus 2 is to the 1st. And b to the 5th divided by b to the 1st power is b to the 4th. And finally, c, 9 minus 3 is to the 6th power. So here is then the length of our rectangle. Alright, so this the last part of this video has to do with scientific notation. Let's say that the number c times 10 to the n is in scientific notation. Okay, what's got to be true about c, that number c, and what's got to be true about n, the exponent. Okay, so let's just look at a number that we could have seen in scientific notation, maybe say 3.5 times 10 to the, I don't know, 3rd power. Okay, and we know scientific notation means that, like this 3rd power, I would take the decimal on the 3.5 and I'd move it to the right 3 places. If it was -3, I would have moved it to the left 3 places. Okay? Alright, so first of all, what's going to be true about this number here, which I'm calling c? Well, can it be 0? Can it be, say, 0.15? Answer is no, it can't be 0.15, because if it was, I would have moved that decimal behind the 1 and had a different power. Protein. And had a different power of 10, right? So I can't have that either, can't have that. Could I have something like 11? Answer is no, I can't have 11, because then I would have moved the decimal place in between the two ones. So this means that the number c is basically in between 1 and 10. It cannot be 10 because if it was 10 I'd have to move the decimal place over. But it can be equal to 1 if I want it to be. Like I could do 1 times 10 to the 13th power. Same thing as 10 to the 13th power. Okay, as far as the n are the exponents. What's got to be true about that exponent? On scientific notation, it could be like 3, 4, 5. I can go down. It could be 0 if I wanted it to be. Can it be negative? Yeah, it just means to move the decimal place over. Can it be fractions? No. So this means that it can only be an integer. So this n has to be an element of the integers. You remember that symbol for integers? So z? Yeah? Okay. So the number c times 10 to the n is in scientific notation when c is in between 1 and 10, where it could equal 1 but not 10, and n is an integer. Okay. In scientific notation, numbers are really easy to multiply. They're really easy to multiply because they're already in multiplication form and they have properties of exponents for the powers of 10. Okay? But what they are not easy to do is add and subtract. They're not at all because you have to take them out of scientific notation first and subtract your numbers and then put them back into scientific notation. So what we're going to do is the one on the left here, we're going to do some multiplication and division of these things. Okay. So let's try this first one on the left here. I've got 4.2 times 10 to the third and 1.5 times 10 to the sixth. Okay, so the first numbers here, this is just straight multiplication. 4.2 times 1.5, I can just do that multiplication. 4.2 times 1.5, okay? And then the powers of 10, I can just add up the exponents. Keep the base the same, 10, and then add up the exponents. 3 plus 6 is a 9. Okay, and then what I need to do is actually multiply the 4.2 times the 1.5. Here, 0, 1, 2, 21. Okay, and then 0, 2, and a 4, which means that this is 6, 3, 0. Move the decimal place over 2. This is 6.3 times 10 to the 9th. Right? You probably didn't think you'd have to multiply by hand with decimals since you're so like dependent on your calculator and stuff. Okay, the division, why don't you see if you can do that one yourself? So of course across the top we can multiply those things together and then use the division property to simplify the bottom. So go ahead and pause your video and give number 2 a try. Okay, so maybe you found that one to be a little trickier than the other ones. The other one that we did together. So notice that I did my multiplication and division by hand. I definitely I hope that you did the multiplication division by hand too, because at some point here very, very soon you are going to have to do those things by hand with polynomials. Anyway, so on this one, whenever I go to simplify the number, the numerical part, I have to multiply 7.5 times 4.5. I get 33.75. Then I divide it by 1.5 from the bottom, and I get 22.5. Simplifying the exponents, the 4 minus the 7 is the negative third power. Okay, but here's the problem. The problem is you don't keep 22.5 for scientific notation. That needs to be 2.25. Right? So you need to move this decimal place one more space to the left. And what might be confusing to you is that, does that mean that this should be to the negative 4 power or to the negative 2 power? So to see what it's supposed to be, why don't we just kind of put this in, take it out of scientific notation and see what it would ultimately be. So to the negative third power means that I'm supposed to move this decimal place 1, 2, to 3 places, so 0.0225. And then if I put it back in scientific notation, I can see 1, 2 places. I need to move it just 2 spaces, so that is 2.25 times 10 to the times 10 to the negative second power. There we go. Alright, so that concludes our lesson on properties of exponents and whatnot. So Again, our objective was simplifying numeric and algebraic expressions using the power property, where you keep the bases the same, add the exponents. The division property, keep the bases the same, subtract them. And power property of exponents, you multiply a power to a power. Anything raised to the 0 power is 1, and whenever you divide, you get a negative power. The negative means reciprocal needs to go down on the bottom. Okay, so I just wanted to repeat those again, just in case you needed to hear them. So here's your assignments, and I'll see you in class, okay?